My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 431. In this lecture, we will try to understand featurization and feature engineering. We will understand various ways to featurize data and also some details about feature engineering. The most important aspect of machine learning is featurization and feature engineering. This is the most important stage. For example, we have already seen for text data, we have seen when we are looking at Amazon food reviews data. For text data, we have seen how to do feature engineering. Featurization is basically about converting some type of data into a numerical vector. Feature engineering is how do you modify it so that it works well with machine learning. Feature engineering is the pre-processing step of machine learning. For text data, we have seen featurizations like bag of words, TF-IDF, average word to vec, TF-IDF word to vec. All these are various methods, various featurizations of text data. All of them are useful. Some of them in some cases, others in other cases. But if you are given some text data, these are the ways to employ typically. These are the techniques that we use to featurize into numerical vector, because at the end of the day all machine learning algorithms works on numerical data, isn't it? So learning featurization is very important. So we have already learned for text data. Similarly, for categorical data, we have learned a bunch of techniques, a bunch of featurizations like one hot encoding mean response rate. We have seen a couple of techniques of featurizing categorical data. Similarly, we have seen very domain specific ways, domain specific methods of featurizing categorical data. Let's look at other types of data. What happens if you have time series data? Now, what is time series data? Time series data is when the information in time series, for example, heart rate. If you look at heart rate pattern or heartbeat looks like this. Time is on x-axis, your heart rate looks like this, isn't it? You have time on x-axis, and on y-axis you have amplitude, isn't it? And this is the time series. Your heart rate can be represented as a time series. So when you have time series data, how do you handle it? Similarly, the other very important application in e-commerce or any form of retail, or anywhere things are sold. On x-axis you have time, on y-axis you could have number of products sold in an hour. This will also have some pattern. Time series data occurs lot of times in real world, like heart rate is one example, e-commerce is other example, like speech is very good example, or any audio form basically can be represented as a time series. Time signal of the waveforms like this, isn't it? So on and so forth. Similarly, you also see stock market data. Very interesting example of time series data is stock market data. So in stock market data, you say this is a time on x-axis, and on y-axis stock price, isn't it? Of course, it goes up and comes down. In the case of stock market data, it goes up and also it comes down. It's have lots of pattern in it. All these forms are very different. So you can actually think text also time series data. Text also can be thought of as a text also can be thought of as a sequence of data, because you have word 1 followed by word 2 followed by word 3 and followed by word 4, so on. Time series, but it's a sequence of data. You can think of text is also as a sequence of data, because one word is following other word, so on and so forth. Time series occurs lot of times. In this lecture we will learn what are some simple techniques to convert a time series data into numerical vector. That is important. We will try to understand it, because once if you convert into numerical vector, then we can apply our classical machine learning algorithms. All the algorithms which we learned till now can easily apply on time series data very easily. So similarly, since we have seen this, there are other types of data. For example, if you are given an image data, let me take image data. There are tasks like in image data is task like detecting face in an image. You have to detect a face in an image, answering whether there is a face in image or not, or recognizing the face. Detection is different from the recognition. In face recognition, we say, in detection we say, is there a face in image or not. In recognition we say, is the face that is there in an image in this photograph belongs to specific person or not. That's what is the face recognition. Similarly, in medical images we have something like in medical images we have x-rays, you have x-rays, even you have MRI scans. Just if you go to medical images, what have you may have x-rays, isn't it x-rays, even I can say MRI scans, isn't it x-rays, you have MRI scans, which are all images. Look up and say whether a patient has specific disease or not, or specific is meeting specific condition or not. So image data is also there in videos. Video is basically an image data plus time series data. It's an image data plus time series data. It's a time series because video runs over period of time, isn't it? You have an image. You can have particular image here. In a video you can have particular image here. Again you can have particular image here. In video you can have particular image here. You have an image at this point. You can have image at this point, and you have other you have an image at this point, and you have other image at this particular point, etc. So it's basically image plus, I can say it is basically image plus time series data. Image data found lot of time in real world. We will learn simple techniques how to encode, simple techniques related to how to encode images, how to convert images into numerical vector. Once if we convert it into numerical vector, once if you convert your images into numerical vector, into numerical data, you can apply all of the classical machine learning algorithms. Just go through these simple concepts. I will continue my lecture on featurization and feature engineering in my next lecture also, that is in lecture number 432. Thank you very much.